Hello, Keith Rucker here at VintageMachinery.org. Guys, today I got a little quick project that I'm going to do for a viewer that helping him out on a little project that he's working on. And this should be a fairly quick, easy, simple project if all goes well. What I'm looking at doing is he sent me a drawing. It's a very simple sleeve or bushing that he is needing for a project that he's working on, which is actually a 1963 BMW R69S motorcycle. And I think this has to do with, oh goodness, it's a sleeve that he needs to put on there regarding some type of custom application he has on that motorcycle. And I can't remember exactly what he said. I was looking on here, seat frame sleeve. That's what it is for the seat frame. He had a custom seat frame built. And basically he needs a sleeve to go on here to take it from one side to the other. There's a little rubber bushing that's going to fit up inside of this, but he needed a sleeve to take it down to the proper size that he needs to fit on his bike. So again, fairly simple project. We're going to get her knocked out. So with that, I'm going to show you the drawing here that he sent me. This is about all I've got to work off of. I've got a piece of just scrap stock that we're going to make this out of, and we'll get it knocked out. Sent on the way, so hopefully he can get his bike up and going. So this is what he sent me, and basically what we're looking at is this is going to be 1 3/4 long. The outside diameter of this is going to be 1.214 inches. He needs the inside diameter 1.025, and he does say he wants that just a little bit smaller, probably about a thou undersize, to have an interference fit. This is where the rubber bushing is going to go up in there. So we'll probably make this 1.024, I think, just to make sure he has that interference fit. Now, we'll be making this out of a piece of solid stock, so we'll be having to drill this out, bore it, and then we'll turn the outside diameter. My game plan here is this piece of stock I'm going to make it from. I'll cut this to length, 1 3/4. We'll face the ends. I'm going to drill a hole through it, then we'll bore that out to size, and then I will mount this on a set of expanding mandrels, and we'll turn the outside diameter concentric with the inside diameter, and we'll be done. So again, should be a fairly simple, straightforward project, and because I said that, we'll probably run into problems. At least that's how it usually goes around here. All right, let's get in there and see what we can get done. All right, I'm over here at the Marvel saw, and step one is to cut this to length. Again, 1 3/4. So I'm just going to come in here. I'm going to cut it a little bit on the long side. We'll face it off at the lathe. So anyway, we'll just start with that. Feed this in there and let it cut across. All right. That'll give us something to work with. So we've got our blank over here in the lathe, and again, we're going to face this off and get that length right. Now, I've already got, the original piece of metal was already faced on the back side, so I'm just working on this side, and we'll cut it to length. I won't have to worry about flipping it back over. We'll come in here, touch off. I just want to get that faced to a uniform thickness. We'll then go in there and measure it, figure out how much more we need to take off. So I'm just going to stop. We just rolled straight out of there, so I'm still on that same plane I was before. I'll take my calipers, and we are measuring 1.821. I'm going to put that in my digital readout. 1.821. I'm putting that in on the Z-axis, and again, I'm going to 1 3/4, which is 1.750. So now I can just keep facing this off. I'll watch my number on the digital readout until I get it to the right length. And I will note that he told me that this length here is not a critical measurement. but we'll get as close to it as we can. Right on the money. 1.750. Okay. Now we're going to go ahead and drill this out and start boring it to size. All right, we're going to start by putting us a little dimple in here to start our drill bit on. I'm just using a center drill, but I'm not going down the center. I'm just using it as a spotting drill. Just spot that center to get it going. Got a 3/8 inch drill bit here to get the hole started, and we're just going to drill all the way through the part. All right, we're all the way through. Slowed my drill down as we go up to this larger drill bit. And again, this is a 1 inch, which is still going to be a little bit undersized. We'll bore it to that final dimension, but we'll go ahead and get this drilled all the way through. There we go. I think we're set up for boring here. I've got a boring bar, and when you're selecting a boring bar, I've got a bunch of different sizes that will fit in different diameters. I always try to choose the largest one that'll fit into the bore that I'm going into. These tend to get a little flex on them when you're using them, so the bigger it is, the beefier it is, the better. It's more accurate. It's going to be able to hold something in tolerance. So, always try to go with the biggest one that'll fit that you have for any particular job. And we should be able to clear that, go all the way through the part, no problem at all. And we're going to 1.024. I should be at 1 inch right now, although that's a rough drill. I think, though, I'm going to kind of sneak up on this inside diameter. The inside diameter is really the critical diameter. The OD is not as critical. So what I think I'm going to do is I'm just going to get this cleaned up. Whatever it is, it is. I just want to kind of get that rough drill bit, get a nice smooth bore in there. I'm then going to put this on a expanding mandrel and take some of the material off the outside. When you're doing a fairly thin bushing like this, if I take the inside to size and then take a bunch of metal off the outside, it's going to relieve some stress, and that could cause that inside dimension to change. So I'm going to take, get this a little bit undersized. We'll machine this outside close to the final tolerance, and we'll put it back in the chuck, bore it to the final size, put it back on the mandrel, and cut the outside. And yes, I'm going to some extra steps here, but again, I just want to make sure that we're able to hit our numbers and things don't move around after we do some machining. So that's kind of my game plan. Take my time, get her done. So we're just going to kind of come in here and set off. I can already tell my cutter needs to go down a little bit. Let me touch off again. And I'm just going to feed in just a couple of thou and feed through. Now I got my expanding mandrel here, and basically the way these work is you got a tapered mandrel and you got a expanding piece that fits up over this, and as you slide that down, this gets bigger on the inside. So this is for a 1 inch size, so right now that slides right up on there. But again, when I tighten that on there, now that's tightened on the inside and it's not going anywhere. I'm going to just kind of bump that down a few times, and we'll put this between centers, and now I can turn that outside, and I'll turn it concentric to the bore that we just cut. Now, because we're turning between centers, I'm going to put a drive dog on here. This drive dog will just, this is going to fit up onto a live center that I got in my chuck. The drive dog will actually hit the chuck, and that's what's going to turn it. This is what's going to turn it. And I'll put a live center in the other end, and we'll be ready to turn that outside diameter. Set up here with the mandrel, and we're starting out at about 1.450. We're going to 1.214. Now, when using a tapered mandrel like this, one thing you want to do is you want to always turn where your work pressure is tightening this up. So this tightens up as it goes this direction. This gets larger. So you want to work in that direction. Now, the way these are set up with the little flat for the dog to go on, it's pretty much going to force you to do that. But in case you have one that isn't that way, if your tool pressure is going against that, you could loosen it up while you're using it. So we'll come in here and we'll just touch off on that. We got a good bit of metal to come off, so I'm just going to do about a 50 thousandths. Let's add some. So that's obviously not 50 thousandths. Must have had some back pressure in this because it slid back a little bit whenever I put it on there. Let's do that again. Much better. We're at 1.436. I'm going to put that in digital readout. 1.436. Again, we're going to 1.214. I'm going to go a little bit oversized. We'll just take a couple passes here. Get another measurement here. All right, we're at 1.297. I'm just going to take it 1.250 for right now. That'll give me a little bit more to take off once we get to our final step here. This will be our final pass for now, but we are going to come back to this. All right, and I'm just going to use the back of my cutter to just relieve that a little bit because it had left a burr on it. So now what I'm going to do is we're going to take this off, put it back in the chuck, and we'll bore it to the final size. And now having that outside material relieved off of it, I'm not expecting a lot of dimensional change or stress relief as we go forward. So let me get back over to the boring bar. So I got chuck back up again. We got the boring bar back out again, and we're just gonna, let's see if we can get that running a little bit better than that. All right, here we go. I'm gonna come in, we're gonna touch off. And I'm just gonna take a little bit to just kind of get a good clean path going through there. I'm gonna take a little bit more. Get our bore mic back in here again. And we're measuring about 10.5 thou over 1 inch, so 1.010, we'll just call it that. I'm gonna put that in my digital readout, 0.010, I'm just gonna say 1015. We're roughly at a half a thou there. We're going to 1024, so let me take a little bit more here. I'm getting down close to the final size here. I got about just a little bit to go, and I'm just gonna, instead of trying to use a boring bar, I'm just using some emery cloth. I got this one wrapped around a little piece of metal, and I'm just kind of polishing that last little bit out. That boring bar was honestly giving me fits a while ago, it just was not really wanting to cut very well for some reason. We got it right here at the number, and I'm still about a thou shy of where I want to be at, so I'm just going to polish it out. Give me a few minutes. All right, we are reading right on 1.024 right there, which is right where we want to be. So I got that inside bore right where it needs to be. We're going to put it back on the expanding mandrel and finish this job up. All right, we have our part back over here on the expanding mandrel, and we left off at 1.250 on that OD. And let's see, we're going to 1.214. I'm just going to make a light pass down through here. Get it fresh cut on there. We'll get a good measurement, put it in the digital readout, and we'll just take this to the final dimension. This measurement isn't super critical, but I'm going to use a micrometer anyway, just because. So we're at 1.221. 1.221. Let me put that in the digital readout. 1.221. We're going to 1.214. And I think I'm just going to dial that right in. Probably a final cut, so I don't want to drag that cutter back across there. See where we're at here. Yep, that's right on the money. All right, I'm going to break those corners and we'll be done. Just got a 45-degree tool here. Break corners on both sides. And that part is done. We can take her out and she's ready to send back to the customer. Well, there you go. One little bushing all knocked out. Like I said, nothing too difficult, nothing too fancy, but we got her done. Well, I know somebody's going to ask, why did I make this out of a piece of solid rather than using some tubing to do it with? It would have been a lot easier had I used some thick wall tubing or something like that. The simple answer to the question is just because I didn't have a piece of tubing on hand here in the shop. I had a piece of scrap metal that I could make this out of to keep the cost down. Had I opted to make this out of a piece of tubing, it would have made the machining a little bit easier, but I would have had to order a piece, probably looking at $20, $30 by the time you have shipping, $40, $50 to get a piece of tubing. Probably a 12-inch piece for 1.75 inch piece is all I needed. Plus, it's going to take a couple of days for it to get here versus I had this piece laying in a scrap pile. Cost was virtually nothing. Time, yeah, you know, it took me a little bit extra time to have to drill it out, but I didn't have to wait 2 or 3 days for it to get here. So there you go. That's the reason why. It's just convenience and cost more than anything else. Making out of tubing would have been perfectly acceptable. And if I was making a bunch of them, you know, tubing would be the way to go. But for a one-off part, it just wasn't worth the extra money and the extra time to have to wait on it. So there you go. With that, guys, that's going to be a wrap. As always, thanks so much for watching. Please subscribe to the channel if you haven't already. Those thumbs up and comments are really greatly appreciated. They do help feed the algorithms over on YouTube and help my channel be recommended to other people, which is also greatly appreciated. Big, huge thank you to those who support the site financially through Patreon and PayPal. Could not do everything we do without all that little bit of extra help there. There are links to that down in the description if that's something you want to help out with. It really does make a difference. And with that, I am going to sign off and get out of here. We'll catch you on the next video again. Thanks for watching.